Well, thank you, Mr. Chairman. Thank all of you for being here today as we discuss this very important subject, which we're going to discuss ways to identify and reduce bias in artificial intelligence in financial services. We've talked about this issue in concept numerous times, but we have not yet gotten deep into what algorithm explainability really means. So I appreciate the chairman holding this hearing. Analytical models of AI and machine learning are best understood, at least to me, when they're broken into three basic models: descriptive analytics, which analyzes past data; predictive analytics, which predicts future outcomes based on past data; and prescribing analytics, where the algorithm recommends a course of action based on past data. There's also a fourth emerging model, which I refer to as the execution model, which automatically takes action based on other AI systems' outputs. I believe the execution model deserves the most attention from policymakers because it can remove the human element in decision making. There are a number of noteworthy recent developments in artificial intelligence that I hope we can discuss today. First, the White House Office of Science and Technology Policy recently released principles for how federal agencies can regulate the development of AI in the private sector. The intent of the principles is to govern AI with the direction on the technical and ethical aspects without stifling innovation. The principles recommended providing opportunities for public feedback during the rulemaking process, considering fairness and non-discrimination regarding the decisions made by AI applications, and basing the regulatory approach on scientific data. The U.S. Chief Technology Officer said the principles are designed to ensure public engagement, limit regulatory overreach, and promote trustworthy technology. Some private sector organizations recommend principles for companies using AI. Those include designating a lead AI ethics official, making sure the customer knows when they are interacting with AI, explaining how the AI arrived at its result, and testing AI for bias. I believe the latter two, explaining results and testing for bias, are important to ensure appropriate use of AI by private sector businesses. A basic but central part of explainability is making sure businesses and their regulators are able to know the building blocks of what went into an algorithm when it was being constructed. In other words, coders should maintain thorough records of what is going into the model when it is being trained, ranked by order of importance. This is also known as logging and can help isolate sources of bias. A similar concept is present in credit scoring. Credit scores are generated by algorithms to create a number that predicts a person's ability to repay a loan. Importantly, it is easy to figure out what is bringing someone's score up or down because the factors that go into the score are transparent. Having a long credit history brings the score up, while the use of available credit brings it down. Additionally, on-time payments are weighted higher than the number of inquiries. With that said, record keeping is a starting point and certainly is not a silver bullet solution to the explainability problem, especially with more complex algorithms. With explainability, we also need to define what fairness is. There needs to be a benchmark to compare algorithm results and evaluate the fairness of an algorithm's decisions. These kinds of paper trails can help get to the bottom of suspected bias in loan underwriting decisions. It is also important to be able to test algorithms to see if there is any bias present. If there is suspect bias, companies can take a subset of the data based on sensitive features like gender and race to see if there is disparate impact on a particular group. Aside from testing for bias, testing can also help companies verify if an algorithm is arriving at its expected results. It is also important for companies and regulators to verify the input data for accuracy, completeness, and appropriateness. Flawed data likely results in flawed algorithm outcomes. I look forward to this discussion on this issue, and I yield back.